In this lesson, we're going to focus on the concept of distributed denial of service attack. Now, a denial of service attack isn't a specific attack in and of itself, but instead is this category or type of attack that's carried out in a number of different ways. Essentially, the term denial of service is used to describe any attack which attempts to make a computer or server's resources unavailable, but it can also be extended to network devices like switches and routers as well. The first category is called a flood attack. This is a specialized type of denial of service which attempts to send more packets to a single server or host than it can handle. So in this example, we see an attacker sending 12 requests at a time to a server. Now, normally a server wouldn't be overloaded with just 12 requests, but if I could send 1,200 or 12,000, that might allow me to flood that server and take it down. Now, under a flood attack, we have a few different specialized varieties. The first is called a ping flood. This attack is going to happen when somebody attempts to flood your server by sending too many pings. Now, a ping is technically an ICMP echo request packet, but they like to call it a ping on the exam. Because a ping flood has become so commonplace though, many organizations are now simply blocking echo replies and simply having the firewall dropping these requests whenever they're received. This results in the attacker simply getting a request timed out message and the server remains online and the denial of service is stopped. The next flood attack we're going to cover is a SYN flood. Now, this attack is a variant on a denial of service attack where the attacker is going to initiate multiple TCP sessions, but never complete the three-way handshake. You can see here how the attacker is sending 4 SYN packets to the server, but they're using made-up IP addresses. The server then replies to those IP addresses in an attempt to establish that three-way handshake, but of course, the other people weren't expecting that call, and so no one responds. This causes the server to set aside resources for these supposed clients while it waits for their response and acknowledgement, but the acknowledgement never comes. If the attacker creates enough requests, the server will simply run out of resources and be unable to establish any real connections with those who really want to do business with the server, and this creates the denial of service condition. To prevent this from occurring, flood guards can be installed in the network. These devices will detect when a SYN flood is being attempted, and it'll block the request at the network boundary, freeing up the server. Flood guards can also be a feature in some routers and firewalls as well. Also, your server can be configured to time out on those half-open requests after a period of time, say 10, 15, or 30 seconds, and this will free up those resources and prevent the denial of service condition from happening too. Intrusion prevention systems also have the ability to detect and respond to SYN floods as they're being attempted. So, now that we've covered the different types of flood attacks, let's move on to our next category, the permanent denial of service attack, or PDoS. This is an attack which exploits a security flaw to permanently break a networking device by reflashing its firmware. This can cause a device to be unable to reboot itself because its operating system is overwritten. It's also called a permanent denial of service attack because a quick reboot won't bring the system back online. Instead, the device has to be taken offline, have a full firmware reload done, and then it can be brought back online. Finally, we have our last one, the fork bomb. With a fork bomb, the attacker creates a large number of processes to use up available processing power of a computer. This attack gets its name because a process is called a fork, and it can be forked into 2 processes and then 4 processes and so on until it eats up all the resources. Now, some people think of this as a worm because of the self-replicating nature, but they're not a worm because they don't infect programs and they don't use the network to spread. Instead, fork bombs only spread out inside the processor's cache on a single computer that it's being attacked with, and it causes a denial of service attack and a denial of service condition, which is why it's considered not to be a worm. Now, there are new denial of service attacks being dreamt up all of the time. Basically, for the exam though, if an attack causes a system to go offline and to stop providing the service that it's really supposed to do to its real users, or it can permanently cause a system to be broken, this could be categorized as a denial of service condition. Now, we discussed the concept of a denial of service attack. We went over all of the different types of them, but most modern systems can't be taken down by a single machine attempting a denial of service anymore. So attackers got smarter, and they created a distributed denial of service, or DDoS. Now, a distributed denial of service attack, instead of using a single attack targeting one server, they use hundreds or even thousands of machines to launch an attack simultaneously against a single server and force it offline to create that denial of service condition. Usually these machines that conduct the attack don't even realize that they're a part of it though. Generally, these machines have become zombies or bots inside a large botnet. And then when they receive that command to attack, they all simultaneously send all of their payloads against a single victim. Now, in addition to most basic forms of DDoS attacks, there is one specific type of DDoS attack called a DNS amplification attack that could be performed. This specialized DDoS allows an attacker to generate a high volume of packets that's intended to flood a victim's website by initiating DNS requests from a spoof version of the target's IP address. This causes the DNS servers to respond to that request and send the response back to the server, thinking that it's valid. Because the DNS request uses very little bandwidth to send, but the response usually takes up a lot more bandwidth, this allows the attack to be amplified against the victim server. Also, if this is happening because thousands of simultaneous requests are being made by a bunch of zombies in a botnet on behalf of your victim server, you can easily become overwhelmed with a lot of information and eat up lots of bandwidth pretty quickly, causing that denial of service condition to occur. We talked about a denial of service attack involving the continual flooding of a victim system with requests for services that causes the system to crash and run out of memory. Now, this usually happens when you're talking about one system attacking one system. But that wasn't enough with modern computers, so we moved up to the distributed denial of service attack, where hundreds or thousands of people target a single server to take it down. Now, in March of 2018, the website GitHub was actually hit by the largest DDoS that we've clocked to date. This is where tens of thousands of unique endpoints conducted a coordinated attack to hit that server with a spike in traffic, and the spike in traffic went up to 1.35 terabits per second. This took the website offline for all of 5 minutes. So you can see how these DDoSes are really hard on a server and can take them down, but not for very long if you can stop them. So your real question probably is, how can you survive one of these attacks? And how can you prevent it from taking down your organization's servers? Well, we have a couple of techniques. The first one is called black holing or sinkholing. This technique identifies attacking IP addresses and routes all of their traffic to a non-existent server through a null interface. This effectively will stop the attack. Unfortunately, the attackers can move to a new IP and restart the attack all over again, and so this is only a temporary solution. Intrusion prevention systems can also be used to identify and respond to denial of service attacks. This can work for small-scale attacks against your network, but you're not going to have enough processing power to handle a large-scale attack or a big DDoS. Now, one of the most effective methods to utilize is to have an elastic cloud infrastructure. If you've built your infrastructure so that it can scale up when demand increases, you can ride out a DDoS attack. Now, the problem with this strategy, though, is that most service providers are going to charge you based on the capacity and resources that you used, so when you scale up, you're going to get a much larger bill from that service provider than you normally were expecting. And you're not getting a return on this investment because this traffic was all wasted. It wasn't generating any revenue for you. So there's actually some specialized cloud providers out there that have taken on this challenge. People like Cloudflare and Alchemy are designed to help you ride out these DDoS attacks. They provide web application filtering and content distribution on behalf of your organization. These service providers are focused on ensuring that you have highly robust, highly available networks that can ensure that they can ride out these DDoS attacks and these high bandwidth attacks. This is going to also give you additional layered defenses throughout your OSI model. It's going to help provide you additional protections.